Okay folks, good morning. Welcome to this overview about the flap and lift augmenting system of the Boeing 747-400. My name is David and it's going to be a pleasure to be here with you for this presentation. First of all, let me introduce myself. My name is David Oliveira. I'm 39 years old, from Rio de Janeiro, from Macaé, Rio de Janeiro. I began my career in 2003. I've been working, back then I worked as an helicopter offshore operations agent, also as a weight and balance controller and business aviation. That were my first step in aviation in 2003, 4 and 5 before I became a Go employee in 2005. And in 2012 I became an aircraft maintenance technician for Go Airlines, a line maintenance technician, and in 2016 I became a maintenance instructor for Go Airlines in Belo Horizonte, Minas Gerais, where I still live. My experience, my background on aircraft maintenance comprises of many aircraft types. Boeing 737s were the most it's the most experience I have, the most experienced aircraft that I have under my belt. Boeing 737 Classics, NG, New Generation and Max. And then I became an aircraft maintenance for Azul Airlines a couple of years ago, where I worked with Embraer E-Jets, Embraer E190 and 195, and also the ATR 72-600. That's the fleet that I have practical experience as an aircraft maintenance technician. What we're gonna talk about today, the contents of what we're gonna talk about today are the operation of the leading edge flaps and the trailing edge flaps of the Boeing 747-400, and also the last topic is about a feature maybe unique to the Boeing 747. That's the flap automatic retraction feature. That's a protection that the system provides to avoid damage on the flap, on the leading edge flaps, and all its associated mechanical linkages and mechanical devices as a whole. So since this is a feature not very well known for the maintenance technicians community, that's something I would like to show you and explain how it works. I heard that the Boeing 707, actually I saw a video of a Boeing 707 presenting a similar feature of automatic retraction upon landing of the leading edge flaps, of some of the panels of the leading edge flaps, but this is something that I learned from the 747, and as far as I know, for all the 747s still flying, still in operation, I think this is a unique feature, a unique characteristic reserved for the Boeing 747, and I'll have the pleasure to be here and presenting those topics to you this morning. Okay, this is the leading edge flaps schematic, quite simple schematic, objective schematic, and the leading edge flaps, you might notice that I refer to it as leading edge flaps. That's right. The Boeing 747 doesn't have slats as we could expect from an airliner. The Boeing 747 works with Kruger flaps for the inboard section of the leading edge flaps, and variable camber flaps for the mid-span and for the outboard sections of the leading edge flaps. That's why they are called leading edge flaps for the Boeing 747s. Okay, so the leading edge flaps are comprised of the inboard section 3 panels, mid-span sections, 5 panels, 1, 2, 3, 4, 5, and outboard section comprised of 6 panels. Those panels are driven by flap drive units, okay? 1 for the inboard section, 2 for the mid-span section, and 1 for the outboard section. Those flap drive units, they are commanded by the flap control units. Those flap control units are electronic devices installed in the E&E compartment, or electrical and electronic compartment of the Boeing 747, and there are 3 of them installed. So the flap control units receive inputs from the flap control lever installed in the cockpit, and the flap control lever tells the flight control unit the position commanded. In this example, the flap control lever is positioning at the position 25 for flaps 25. So a signal is sent to the flap control unit. This signal is sent using a transformer, an RVDT, rotary variable differential transformer, and the RVDT tells logically that to the flight control units the position commanded by the crew, and then the flap control unit will electrically drive the flaps, allow the flap drive units to operate the flap panels using pneumatic power or electric power for the leading edge devices. The leading edge devices, primarily speaking, they use pneumatic power, but in secondary operation or secondary mode, when something goes wrong with the pneumatic power or the primary power source, electrical power kicks in order to operate the flaps, the leading edge flaps. So the flap control units control the flap drive units by allowing the flap drive unit to choose whether it's going to use pneumatic power from the bleed air ducts or electrical power. The primary mode of operation is always using pneumatic power. If something goes wrong, if pneumatic power is lost, then electrical power kicks in, as I said before. The flap control units also is responsible for sequencing of the flaps, which panels go first and which panels goes last during extension or retraction. There is an order of extension and retraction, as we can expect. And also the flap control units monitor and protects the system against disagree conditions or uncommanded motion. When one of the flaps goes to a position not commanded by the crew, the system, the flap control units will shut down the whole system in order to prevent any damage or any problems regarding controllability of the aircraft. Okay, so this is a simplified schematic of each drive unit. The drive unit primarily receives pneumatic power. Pneumatic power will drive this motor, this pneumatic motor, and this pneumatic motor will convert pneumatic power into mechanical movement, and from there the flaps can be driven towards extension or retraction using pneumatic power. If something goes wrong, if there's no pneumatic power available, an electric motor will drive the flaps. It is important to notice that the flaps will be driven into secondary mode automatically. There is no action required by the crew when this happens, because the crew will still use the flap control lever to control the flaps. The only difference is that the indication will be different. Normally the crew has an indication like that. This is called the combined indication. Why do they call it combined? Because it's a very simple indication, and when everything is fine, like in this indication here, the flap were commanded to flaps 20. The green the green bar and the green digits here means that the flaps are actually at the commanded position, so everything is fine. When the flap is still extending or retraction to the commanded position, those digits here will be magenta, like here. Magenta digits and magenta line indicating that the flaps, the actual flap position is not in the commanded position, is not agreeing with the commanded position, but eventually the flaps will agree with the commanded position, and when everything is fine, this is the indication the crew has, the combined indication. But there is also the expanded indication, like this one here, actually like those three indications, but they are different between them. This is the secondary indication. As we are talking about leading edge flaps, we have the indication here that the leading edge flaps, all the three segments for each wing is properly extended. But some flap group, either leading edge flaps or trailing edge flaps, some of them or one of them or any of the groups, they are actually being operated, they are actually being driven in secondary mode. If this is for the leading edge flaps, some of these groups are being driven electrically, but again, there is no action from the crew. They will only get this expanded indication to tell them that some of those groups are being operated in secondary mode. Okay, those indications here, they are considered abnormal indications, and when something abnormal comes up or happens, they will get the expanded indication as well. In this example here, those are abnormal indications. This indication here means that the outboard left wing leading edge flaps, the drive unit have failed, and have failed with the leading edge flaps retracted. This indication here means that the position sensor for the mid-span left wing flaps, leading edge flaps, the position sensor is not working, is unavailable. And this indication here means that the drive unit for the inboard leading edge flaps for the left wing has failed, partially opened, or even partially extended, or even extended. This indicates that the flaps are not in the retracted position, but the drive unit failed with the leading edge flap out of the retract position. And those indications here are normal. Fully extended leading edge flaps in transit, and leading edge flaps retracted. And this indication here is when the alternate flaps mode of operation is being used. The alternate flaps requires an action from the crew. Usually the alternate flaps operation is selected by the crew when they lose the flight control units, all the three of flap control units, or 2 RVDTs are lost. There are a total of 3 RVDTs, one for each flap control unit, but if 2 out of 3 RVDTs are lost, the pilots won't be able to command the flaps, so they can use the last resort, which is the alternate flaps switch, arm switch. Before using this rotary switch, they will push this button, the alternate mode is presented, this alternate caption here comes on, and then the pilots can use the extend position or the retract position to operate the flaps accordingly. If they want to extend, they put the switch here. If they want to retract, they put the switch here, and they put in the off position when they want the flaps to be stopped, when they want the flaps to be stationary. They will use this indication here. As soon as the crew pushes this button, this expanded view, this expanded indication comes on. Notice that there are differences between the secondary indication, the expanded indication for the alternate flaps and the expanded indication for the secondary mode of operation. In the expanded indication for the alternate flaps, there is no command indication like in here and here. You see, this is the 30 position commanded by the flap control lever. This is the 5 position commanded by the flap control lever. But when the pilots use the alternate flaps mode of operation, the flap control lever is no longer used. They will use only this rotary switch here to operate the flaps. So all they have are those indications here: flaps 1, flaps 5, 10, 20, 25, and 30, and they are responsible at all times to monitor the flaps position according to their demands. So if they want the flaps to be in 5 position, they will put the switch to extend until the flaps reaches the 5 position, and then they are required to put the switch back to off so the flaps won't be extended further. So in summary, there are 3 leading edge flap sections per wing: midboard, inboard, midspan, and outboard sections, 4 flap drive units used for each wing, and 3 FCUs to work for the left wing and the right wing flap drive units. And those were the details about the leading edge flaps. Now we're going to talk about the trailing edge flaps. Okay, the trailing edge flaps, they work quite similarly in comparison with the leading edge flaps. The trailing edge flaps are they are driven by 2 drive units. One drive unit, or the outboard flap group drive units, will drive the outboard flaps as shown here in the schematic. The same outboard flap group drive unit will drive the outboard flaps for the right wing as they are mechanically linked. This drive unit is driven using hydraulic power from system 4. So if hydraulic system 4 is lost, the drive unit will revert to secondary mode of operation using an electric motor, and those outboard flaps will be driven electrically. So only the outboard flaps will be driven electrically in secondary mode if the hydraulic system 4 is lost. The inboard flap group will still working in primary mode using hydraulic power. Same works for the inboard flap groups. If the inboard flap group drive unit stops receiving hydraulic power from system 1, the inboard flap group drive unit will operate using the electric motor, the integrated electric motor, to operate the inboard flap group. Same happens with the flap on the right wing, the inboard flaps on the right wing. So the primary mode of operation of the trailing edge flaps uses hydraulic power using an hydraulic motor. This hydraulic motor will convert hydraulic pressure into mechanical action. So this is the main difference between trailing edge flaps and leading edge flaps. Again, leading edge flap uses pneumatic power, and trailing edge flaps uses hydraulic power as the primary mode, in the primary mode of operation, as the main source of power. If something happens, electric power will drive the electric motors, and the flaps will be driven using electric power. Something important to point out as well is that the secondary or alternate mode using electric power, the extension and retraction of the flaps will be slower when compared to the primary power source, either pneumatic or hydraulic power. So electrical operation of the flaps, either in secondary mode or in alternate mode, the flaps will operate in a much slower speed than in primary mode. The same happens with the alternate flaps mode of operation. The crews pushes the alternate button and positions the switch to retract or extend, and as you can see, the electric operation goes direct to the drive units. They don't use the flap control units. So the flap control units are responsible for logic in the operation of the flaps, right? So all the protections will be lost when when alternate flaps are being used. So no protections for asymmetry, disagree, uncommanded motion, or load relief will work when the alternate flaps mode of operation is in place, because the operation of the alternate flaps is simplified, is an open loop as the manual says, so it won't go to the flap control units. The flap control units will be isolated from the system, and electric power will drive the flap drive units by themselves, by itself. The electrical power, the alternate flaps, they don't use the flap control units, so all the protections are lost. Just to inform you a little further, the load relief protection is a protection provided by the flap control units to avoid structural problems with the flaps when they are extended to position 30 or position 25. For example, if the aircraft is being flown using flaps 30, if the crew exceeds 180 knots, the flaps will automatically retract to flaps 25. If the crew keeps pushing and keeps exceeding, keeps accelerating, if the airspeed goes greater than 210 knots, the flaps will retract to position 20. Automatically, the flap control lever will not move at all, but the crew will receive an indication. The indication they will receive is the position of the flap going up, and the actual position, going up, this white bar, and its commanded position will turn from green to magenta to tell them that the flaps are not in the commanded position. So they will receive an indication about that, and also a message, an EICAS message called flap relief. Flap relief meaning that the flaps are being relieved from that position, relieved from that excessive air load due to the high speed the aircraft are flying in. So this is the flap load relief protection. All those protections are lost once the alternate flaps are being in operation by the selection of the flight crew. So in summary, there are two trailing edge flap groups per wing: the outboard trailing edge flaps and the inboard trailing edge flaps. The outboard and the inboard are mechanically linked to the right wing, to the opposite wing, so they work. The outboard flaps work together with the outboard flaps of the opposite wings, and the same happens with the inboard flap groups. And this placard here is installed by this switch here on the left side of the alternate flap switch, so the pilots can monitor the speeds they have to maintain in order to avoid problems with the flap position. So they have a reference there to monitor the flap operation according to their airspeed, to their actual airspeed. And for the indications, those are the expanded indications the crew might receive. This is the combined indication. When the expanded indications are in place, those are the representations of the trailing edge flaps. Outboard groups, trailing edge flaps, outboard group for the left wing, inboard flaps for the left wing, inboard trailing edge flaps for the right wing, and outboard trailing edge flaps for the right wing. Those are the representations for the expanded indication. So now I'm gonna show you a video showing the feature of the automatic retraction of the inboard flaps, the leading edge flaps, and the mid-span leading edge flaps. These groups, they will retract upon thrust reverser selection, because when the thrust reverser is deployed, the airflow, the violent airflow coming out from those positions here, from the cascades, will strike the panels, the leading edge panels, and this will cause great vibration. This will cause great vibration, and this vibration is very dangerous for the panels, as they can suffer from vibrations. Of course, they can suffer damages not only on the panels but also on the links, also on the internal devices that are involved in the operation of the leading edge flaps. Again, only the inboard section and the mid-span section, only those sections will retract automatically upon thrust reverser actuation upon landing. The outboard section will remain in place, and this section won't move upon thrust reverser selection. So let's go to the video and check it out. Okay, this was the presentation about the flap and lead augmenting system of the Boeing 747-400. This was an overview. I hope you guys enjoyed this overview, and thank you so much for making time and being here for this presentation. Thank you so much.